Okay. Hope I can do them. I can do most of them. Probability can be pretty hard. Some of them can be really difficult. Okay. Okay. Other than a 2. How many 2s are in the deck? Actually 4. Decks of cards are used as a tool for teaching probability. But it's amazing how many students don't know a deck of cards anymore, because most kids don't play cards now. Video games are kind of taken over entertainment. But a deck of cards has 4 suits, 13 cards each, and there's 1 through 13 basically on each suit. So there would be 4 2s in the deck, which means how many cards other than a 2 are there? So there's 48 ways to get a successful pick, right? Divided by the number of cards that are in the deck, 52. Now I can reduce that fraction a little bit. Let's see. I can do it a couple times. 12/13 would be the probability of drawing something other than a 2. In other words, a 1, a 3, a 4, a 5, a 6, all the way through 13. Okay? Now let me guess, there's a second part to this problem. No? Yeah, usually you leave it as a fraction. Well, it depends. Not always. But probability is defined as a fraction. It's the number of successes over the number of possibilities. There were 52 cards in the deck, and 48 of them were not 2s. So it's the number of success divided by the number of possibilities. That's usually a ratio. So we tend to leave it as that, although if they ask, a lot of probabilities are expressed as percentages, like there's, what'd you say it was, 92%? So 0.92 would be a 92% probability. Okay, so either way is a good way to express it. Okay, what else? These aren't too hard, but trust me, probability can get tough, really tough. A friend of mine called me once who plays poker, and he said, I'm playing in a poker game and 2 different people had a club flush. And there's only 13 clubs in the deck, and one person had 5 and another person had 5. And he says, what's the probability of that? And I says, well, I don't know. That sounds like about a 45-minute problem. That's how hard it would have been. So, but simple ones aren't that hard. So what else do you got? That last one was definitely a simple one. Well, let me ask you. Go ahead. I'll always prefer your problems, but I was going to add a wrinkle to that last one. Okay. Okay. So you want to know the odds of selecting the proper number? Okay. Let's take a random 4-digit number. How many possible 4-digit numbers could I have written? I could have written 0001. I could have written 0002. And anything in between up to that, right? In other words, dot, dot, dot. So there's 9,999 different ways that you can write a 4-digit number. Okay? So that's the possible ways you can write a 4-digit number. And if it has to be in the specific order, there's only one answer. So it's 1 divided by 9999. That's the probability of winning the lottery, assuming that you only have to pick a 4-digit number, using zeros and nines. And in fact, if you include 0000 as a possibility, then there's actually 10,000. So it would be 10,000, not 999. So 1 over 10,000, which is like 1/100%. That number is this. That's your chances of winning the lottery. Let's go back to that other problem for a moment. What's the odds of drawing a 2 from a deck? Not the odds of a non-2, but the odds of a 2. How many 2s are there? Okay, well, let's put it as a fraction, because the one advantage of making it a fraction is it explains it to you better. In other words, there are 4 2s in the deck, there are 52 cards. That's the odds of drawing a 2. If you give me a percent, I can't really go backwards to this easily. So until we get a final answer, let's use this, okay? Well, that's equal to 1/13. Okay, which is 8%. However, now I'm going to change the problem. Let's say you draw a 2 the first time you draw it. And you hold it out of the deck and you draw again. What's the odds of you drawing a 2 now? In other words, first time you draw a 2 successfully and you leave it out of the deck, now what's the odds of you drawing another 2? In other words, a second 2. How many successes would there be? No, let's not do it that way, Brandon. In other words, there are 4 successes, but you already took one of them. So how many 2s are left in the deck? 3. How many cards are left on the deck? Exactly. In other words, it changes both the top and the bottom, knowing that a 2 is gone. So that is 1/17. So the odds of drawing 2 2s with 2 picks from the deck are 1/13 times 1/17. Not very big. What is that? 1 over 191? And notice they're different, because the first 2 was only 1/13th chance. And the second 2, given the fact that you had a 2 already, was even slimmer. It was only 1/17th. So when you're doing, there's this thing in probability where it's with replacement and without replacement. Okay? If you draw a 2 and you put it back in the deck and shuffle the deck up, then the odds of you drawing another 2 are still 1/13. There's still 4 2s in there, and there's still 52 cards. That's called width replacement. But in reality, when you're actually playing cards, you don't replace. You draw a 2 from the deck. Now, let's say you're trying to make a pair of 2s, playing poker. Are you familiar with No Limit Hold'em at all? You ever watch it on TV? You get dealt 2 cards. And so if I want to know the odds of getting a pair of 2s, well, the first card, the odds are 1/13. But if you've already got one and you're trying to get a second one, the next odds are 1/17. So the odds of getting a pair of 2s specifically is 1/191. In other words, you multiply these two together. When you're dealing with probability where both things have to happen, then you multiply the numbers. In other words, what's the odds, if you flip a coin, what's the odds of flipping 2 heads in a row? What's the odds of flipping? No. What's the odds of flipping a head the first flip? 1/2. That's all right. I don't have any problems with you using percentages. I just like to think in terms of ratios, fractions, because that's what probability really means. Successes divided by possibilities. So if you're going to flip it heads twice in a row, the first heads is 1/2. Second heads is 1/2. Both of those have to happen. So what's the odds of flipping 2 heads? Multiply those 2 fractions. 1/4. 1/4, which is what percent? If you are going to convert it to a percent, yeah, there you go. And the odds of flipping 2 tails would also be 25%. And the only other possibility is to flip heads first, tails second, or tails first, heads second, and those are each 25%. And that's the other thing about probability is that all possibilities, the probabilities always add up to 1. In other words, flipping a heads is one possibility. The only other possibility is flipping a tails. Those two have to add to 1. Always. No matter what you're talking about. All the probabilities of each thing, let's say you have a spinner, a wheel that's got 8 numbers on it. You have a thing that spins around. And what are the odds that it'll land on that number, that number, that number, that number, that number? Well, they're 1 and 8, right? Assuming that they're each equal space, equal area, rather. So if I spun this thing, each one of them would have a 1/8 possibility of landing on it. Add all of those together, you're going to get 1. 1/8, 8 times adds to 1. All right, what other probabilities do you have? Okay. They're what? Okay. That means that there's no overlap. I think. I'm not quite sure what it means. What's the question? So you've got this symbol and you got this symbol. Okay? Is it so the probability of A is 0.3. So if it's, so I'm not quite sure what that means. You're not multiplying them together. You are? Okay. Okay. That's what I thought. In other words, yeah, it's the probability of A plus the probability of B. And I know what you mean now about being jointed or not disjointed. If they are jointed, then it's the probability of A plus the probability of B minus the probability of A union B. Or rather, this should be upside down. I think it's this. In other words, if there is some overlap, then this is the formula, if they're jointed. And jointed or not jointed means are they independent of one another? In other words, if they're not jointed, what you call not jointed, then you're either going to get A or you're going to get B or you're going to get something else, but you won't get. In other words, if you're drawing Venn diagrams and they're disjointed, it's like that. If they're jointed, it's like this, where there's this section right here where there's a probability that both can occur. That's what jointed means. It means dependent or independent, basically. This, when you said they weren't jointed, we're looking at this model. So the probability of A or B is adding them together. But if you look at over here, you got to subtract out that part right there. Because what we really want is, in the situation on B, they're looking for this area, which is the first full circle plus the second full circle minus the area of overlap. Hence you get that. Now, I might be using the wrong symbol here. Let's see, it's A union B, which I think is A and B, or A, no, I think this is the and. This is A and B, I think that's A or B. I don't know, am I right? It's been a while since I've looked at probability. I'd have to open my book to be certain. But that's what they mean when they say it's disjointed, is there's not a possibility of both of them happening together. In other words, this doesn't exist because it's disjointed, so it just becomes that there. All right, what else you got? Okay, well, let me think. There's so many different kinds of probability problems and so many different degrees of difficulty in them that I'm reluctant to make one up. Okay, there you go. Let's try one of those. Okay. Okay, so there's 5 reds and how many yellows? There's 5 reds. There's 4 yellows. And what's the other color? And what else? That it? Oh, 3 blues. That's okay. Now, I haven't put them all on there. I understand that your spinning wheel has 3 blue spots, 5 red, 4 green, and 4 yellow, and that takes up the whole wheel, right? And the area of each one is the same, correct? So what's the question? What are the odds of spinning a blue? Okay, so let's look at the probability of a red. Remember what we need, number of successes over number of possibilities. That's the way we're going to get it. Usually it's almost easier to do the bottom first. What are the number of possibilities? How many different spots can you land on when you spin it? There's 4 colors, but there's 16 different slots, right? So there's 16 different possibilities. How many of them are red? Okay, so that's the odds of spinning a red the first time. And you said followed by blue? Or followed by what? What color did you say? A yellow. Okay, so I've got to spin a red the first time. The odds of that are 5 over 16. What are the odds of spinning a yellow? And since both of them have to happen, I'm going to multiply them. When both events have to occur, then it's and it requires multiplication. If it's or, it usually requires addition. In other words, your previous question was an or question. It's probability of A or B. It was 3/10 plus 1/10. But if it was the probability of A and B, it would have been 3/10 times 1/10. This is an and, because they've said you got to roll a red and you have to follow it with a yellow. So it's an and problem. Okay, and the probability would be 5 over 64. And see, I wouldn't even worry about turning that into a percentage. I would just leave it as a ratio. There's no need to do the math. Unless your teacher specifically says, give me your answers in percentages, you know. But ratios are really the way you get to the percentage. You always go through the ratio. Okay? 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 Blue, then green, then red. So we're just going to figure out the probability of blue, multiply it by the probability of red, then by the probability of green. It doesn't really matter the order. So the probability of blue is what? What's the next color? So followed by green or yellow. What was the three colors? I didn't. Blue, then what? Blue, then green, then what? Okay. So blue, then green, then red. So all three have to happen, you're multiplying. And you can reduce a little bit, but not much. Let's see where else I can reduce. So I got 15 over 16 times 64, whatever that number is. Now is when you might want to pull out a calculator and convert that to a percent. But problem with percentage is you're going to round it off, usually. So it's not precise. Whereas these fractions are precise. They are exact. There's no rounding off that's been done. What else? Actually, we're just about at the half-hour mark. If, yeah. Okay. Well, we can call it a night then. So you have a good rest of your evening, and I'll talk to you next time, Brandon. Thanks for accommodating my altered schedule a little bit. Okay. Thanks. Bye-bye.